So this lesson is going to be having a look at oxidation numbers and how to calculate the oxidation numbers of different elements within a reaction, and therefore to figure out which ones have been oxidized and reduced. So there are some rules here. The first main rule is that if an element is by itself, it has an oxidation number of 0. The next one that you should really look for is fluorine here. So fluorine is always -1. And this is very similar to when you'll have figured out the charges and the ionic equation. It's a very similar skill. So group 1 always have +1. Group 2 always have +2 oxidation number. Hydrogen normally has a +1. It can have a hydride, and that comes up in year 13. But most of the time it's +1. Oxygen is normally -2. However, there are the odd exceptions. And chlorine is normally -1. And then for the rest of them, you go based on their groups. So if it's in group 5, it's going to have a -3 oxidation number. However, these are your starting points. And once you've got these, you then work around them. So let's have a go at a couple of examples. So first example here is combustion of hydrogen. Now, because these are on their own, oxygen and hydrogen are on their own, they both have an oxidation number of 0. Once you light the hydrogen and you combust it, the hydrogen is going to become +1 and the oxygen is going to become -2. Because it's H2, that's 2 times +1 gives you +2 and then -2. You don't actually have to worry at all about the balancing. Okay. Now have a look at this one, which is an ion. So sometimes they'll give you an ion to have a look at. Now, the key bit here is that there's an overall charge. Now, if I take oxygen, so I'm going to start with oxygen, and oxygen has got a -2. However, there are 4 of them. So overall, the negative oxidation number is -8. Now, that might make you think that actually this is going to be +8. But people always forget about this bit. So in reality, you need a -2 left over. As a result, you're going to have +6. The oxidation number of the sulfur in this case is +6 because 6 minus 8 equals -2. Now, there is another example of there's another type of oxidation number here, because if we oxidation reaction, because if we go back and we have a look at this reaction, the oxidation number of the oxygen goes down, so it's been reduced, and that's how we figure out which one's been reduced. The oxidation number of the hydrogen's gone up, so that's been oxidized. Well, if we give you this one as an example, hydrogen's always going to be +1. Because it's hydrogen peroxide, it has to have an overall charge that's balanced, or an overall oxidation number that's balanced. That's H2, so oxygen in this case is going to have an oxidation number of -1. Now over here, oxygen's on its own, so it's 0. Water, as we've said before, is +1 and -2. Okay. Now, if we look at most examples will have one element that gets oxidized, one element that gets reduced. However, the hydrogen is +1 there, and the hydrogen is +1 there. The oxygen goes from -1 to 0, so it increases. So in this case, it gets oxidized. It goes from -1 to -2, so it gets reduced. So as a result, the oxygen is both reduced and oxidized in the same reaction, and we call that a disproportionation reaction. A disproportionation reaction.